Aeroplanes are unlike any other form of transport in that the slower they move, the more dangerous they become. Fly too slowly and the aeroplane will stall, having lost flying control, and will simply fall out of the sky. The stall speed of an aeroplane varies depending on a number of factors, such as type of aeroplane and weight. Regardless of type, increase the weight and you also increase the speed at which the aeroplane will stall. To be technical, it may be said that the stall speed varies according to the loading on the wings or the requirement for lift. If flying slow has its problems, so also has high speed. The control surface to be fully effective at slow speed may be too effective, difficult, or even too violent in action at high speed. In addition, the controls at high speed may also be oversensitive. These problems have been overcome by the use of power-operated controls, which, when used, means that the pilot cannot feel the controls unless it is artificially introduced. In these days of high fuel costs, an aircraft must be flown at the most economical height and speed for its weight. A number of other factors must also be considered, such as distance and winds. Generally, with jet propulsion, the faster we fly, the more efficient this form of propulsion becomes. Also, the higher, the better, within reason. The usual practice is to take off into wind, that is, with the wind blowing into the nose of the aeroplane. There are several reasons for doing so. More lift, giving a shorter takeoff run and the lowest ground speed at the moment of takeoff. It reduces the tendency to drift and so reduces the strain on the undercarriage. Better directional control, especially at the beginning of the takeoff run when at slow speed. If for some reason the takeoff has to be abandoned, what is known as the accelerate stop distance is reduced. All this aside, the pilot may, for whatever reason, elect to take off downwind, that is, with the wind behind the aeroplane, after taking into consideration the aeroplane's weight, runway length, and the strength of the wind. Runways do not always point in the direction of the wind, and often there will be a crosswind component. It might even be at right angles to the direction of takeoff, in which case, if the wind is sufficiently strong, you may notice a tendency for the aeroplane to drift sideways. The speed at which an aeroplane becomes airborne depends on a number of factors, including weight and the way the aeroplane has been configured. For example, what flap settings have been selected. Like the takeoff, an aeroplane generally lands into wind. This is done so as to reduce the forward velocity of the aeroplane relative to the ground. As with the takeoff, there may also be a crosswind component. The length of time and runway it takes to bring the aeroplane to rest after landing depends on its touchdown speed, which will depend on a number of factors such as weight, how the aeroplane is configured, and wind strength. Obviously, a strong headwind component will also have a greater effect on the aeroplane's speed along the runway. Theoretically, we want to land at the slowest speed possible, yet still have total control of the aeroplane. There is perhaps no other weather phenomenon more likely to disturb the comfort of cabin crew. There are certain parts of the world where it is seldom encountered at lower altitudes, and others where it can be relied upon to put in an appearance. It also makes itself felt at higher altitudes and cannot always be predicted. What is turbulence? The formal explanation is that turbulence is an irregular motion of the air resulting from the formation of eddies or vertical currents in the air. Well, what are the causes of turbulence? There are several. Friction between the air and the ground can be experienced in the lower portion of the airstream, characterized by a marked choppiness. Turbulence may result from heating of the Earth's surface by the sun. In the summer, bubbles of heated air, sometimes hundreds of meters in diameter, form next to the ground and ascend through the surrounding air one after the other. Each current ascends with increasing speed until it reaches a level where the temperature of the ascending air is the same as that around it. Again, this is more often to be found at lower level. Frontal systems also bring turbulence, and is due to the uplift imparted to the warmer air by the sloping frontal surface and friction between the opposing air currents of the two air masses. We can associate thunderstorms with the passage of frontal systems, which present special problems to flight as a result of drafts, gusts, hail, lightning, and icing. The cloud most associated with thunderstorms is called Cumulonimbus, heavy masses of cloud with vertical development extending to well above freezing level. In the tropics, this type of cloud can rise to well above 20,000 feet. Clear air turbulence, or CAT as it is known, may be found at any level, but is more likely to be experienced at high altitude and is a function of differing jet streams. Because it cannot always be predicted, this form of turbulence can quite often catch cabin staff unawares. We hope that this program has helped you to better understand the environment in which you fly. Other programs in this series will help add to your knowledge.